Heidi ho everyone. Today we're going to be looking at Unit 4, Lesson 4, Rectangular Notes. So we have a vocab word, so check your vocab sheet for the definition of rectangle. So properties of rectangle. A rectangle is a parallelogram with 4 right angles. That means 90-degree angles. From this definition, you know that a rectangle has the following properties. All 4 angles are right angles. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonal bisect each other. So in addition, we also have this following theorem: if a parallelogram is a rectangle, then its diagonals are congruent. There we go. Now we can move. So example 1, use properties of rectangles. So the coach is making the basketball team run a new drill along the diagonal of the court. If BC is 94, so BC is this top part right here, that's 94 feet, and FC, that's the diagonal, is 106.5 feet, we want to find DG, that's half of the diagonal. So again, we know that this is a rectangle, so FC, line segment FC, is going to be congruent to line segment BD. That's the other diagonal in this rectangle. Again, as I said, FC is going to have the same, because if it's congruent, it's going to be equal measures to BD. Well, if FC is 106.5, BD is going to be 106.5 feet. So if this one is 106.5, by the theorem, this one is also going to be 106.5. Well, to find that whole length, we're going to take the two parts of the diagonal. So DG plus BG equals the whole diagonal, which is BD. Well, if the two parts together are equal, then I can just say that DG, and I can substitute BG with DG itself. DG equals BD. This is the same, so I can add those two together. It gives me 2DG equals BD. Divide by 2, I get DG equals half of BD. So half of 106.5. Type that into your calculator. You get DG equals 53.25 feet. So that diagonal segment right there is 53.25 feet. So let's continue on using properties of rectangles. So let's take a look at the next example. So we have quadrilateral ABCD is a rectangle. If the measure of angle BAC equals 3x plus 3, and the measure of angle ACB equals 5x minus 1, we want to find x. So we got some notes here. So since this is a rectangle, we know that the measure of angle DCB is going to be 90 degrees. DCB, this whole angle right here, is going to be 90 degrees. And because rectangles are parallelograms, angle ACD is going to be congruent to angle BAC. So it's going to help us out in a little bit. So again, we want to figure out x for this. So I'm going to start building it up. I have A, C, D, and I have A, C, B is going to give me this whole angle, which I know is 90 degrees. So measure of angle A, C, D plus measure of angle ACB, ACB equals measure of angle DCB, but we know that's going to be 90 degrees. So on the next step, I'll put 90 in there. Well, using this idea that we have over here, ACD is congruent to BAC, which we have information about. So I can substitute in, since they're congruent, they're going to be equal measures. This is going to be measure of angle BAC plus measure of angle ACB equals, and as we said, this is just 90 degrees. Well, now I'm going to put in the information that they gave me at the beginning. So 3x plus 3 plus 5x minus 1 equals 90. Collect my like terms. So that gives me 8x plus 2 equals 90. Subtract 2 from both sides. I get 8x equals 88. Divide by 8, I get x equals 11. So it just said find x, and I did. X is equal to 11 in this case. So if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So you want to prove that this is a rectangle. So if AB equals 50 feet and BC equals 20 feet, CD equals 50 feet, AD equals 20 feet, AC equals 54 feet, and BD equals 54 feet, prove that this is a rectangle. So what do we know? So we know AB equals CD from this information that we got in the beginning. We know that AB right here is 50, and then we also know that CD is 50 as well. What else do we know? We know that AC equals BD. AC, that's the whole diagonal, that is 54 feet, equals DB, which is also 54 feet. So the diagonals are equal to each other. So we know they're equal, so that means that they are congruent by the definition of congruence. AB is congruent to CD, and then AC is congruent to BD. So because they're congruent, we have, as we said, we know that this is a parallelogram because AC is congruent to BD. We know ABCD is a rectangle by theorem 2.14. So by that theorem that we just learned, we know that this is a rectangle. Let's take a look at our last example. So we want to identify rectangles on the coordinate plane. So we have this quadrilateral. It gives us the vertices. We want to determine whether GHJK is a rectangle by using distance formula. So we want to prove that the opposite sides have the same length. So if they have the same length, then we have a rectangle. And then we're going to deal with the diagonals as well. So we're going to start off with GH. So I'm going to use the distance formula for GH. This is going to give me -3 minus 3 squared plus 0 minus 2 squared. Well, that's going to give me -6 squared plus -2 squared, which is 36 plus 4, which is 40. I'm going to keep chugging along here. HJ. So we did GH. Now we're going to do HJ. Now, actually, let's do KJ. Let's do KJ since it lines up. Square root. So this is going to give me -2 minus 4 squared plus -3 minus -1 squared, which equals -6 squared plus -2 squared, which equals 36 plus 4, which equals 40. So opposites have the same length. Now let's figure out the other two opposites, the shorter side opposites. So we're going to start off with HJ. So that's going to give me the square root of 3 minus 4 squared plus 2 minus -1 squared. What is that? Well, that is -1 squared plus 3 squared. So that's going to give you 1 plus 9, which is 10. So this side is the square root of 10. Let's figure out GK. GK. So that's going to give me -3 minus -2 squared plus 0 minus 3 squared, which equals -1 squared plus 3 squared, which is 1 plus 9, which is the square root of 10. So far our sides work. Our opposite sides have the same length. Now we got to deal with our diagonals. So diagonals. So let's start off with our first diagonal is GJ. So this is going to be the square root of -3 minus 4 squared plus 0 minus -1 squared. So that's going to give me -7 squared plus 1 squared, which is the square root of 49 plus 1, which is the square root of 50. So we need the square root of 50 from our other diagonal to make this a rectangle. So our other diagonal is KH. So this is going to be -2 minus 3 squared plus -3 minus 2 squared, which is equal to -5 squared plus -5 squared, which is equal to 25 plus 25, which is equal to the square root of 50. So we have the diagonals being the same, so we have a rectangle. All that work to show us that we have a rectangle. So you're going to take a minute, summarize what we've covered today. We covered how do you find a rectangle given our theorems, and then you're going to use these ideas to help you out with the practice. Have a great day.